This is the sleep study of UNLV. We are group number 23, and this is for Psychology 210 with Dr. Ullman. Our research question investigates if college students that receive closer to 8 hours of sleep a night perform better academically than their peers that receive less than 8 hours of sleep. During this pandemic with COVID-19, or the coronavirus, going on, many college students have strayed from their usual healthy sleeping schedules, and we suspect that this, in turn, is affecting their productivity and their performance in their classes. Our research question dives into this topic by examining the hours of sleep that a group of college-age students gets, as well as their ability to perform academically based on their rest and their wellness. For our conditions, our independent variable is going to be hours of sleep, and our dependent variable is the participants' test scores. We have 3 treatment groups. They are all college students that are aged 18 to 28. Group 1 is going to receive 5 hours of sleep per night. Group 2 will receive 6 hours of sleep per night, and Group 3 will receive 7 hours of sleep per night. We do have a comparison group as well. This is going to act as our control group, and there's only one of these. It is also college students that are aged 18 to 28, and they're receiving 8 hours of sleep per night because this is like the standard, healthy, suggested amount of hours that you're supposed to get each night. Each group, treatment groups and comparison groups, all have 3 participants each. So we have 4 groups in total with 3 participants. The statistical technique that we're going to use for this is going to be an independent t-test since we are testing more than 2 groups. T-tests are used to determine whether or not there's a statistical difference between the means of 2 or more groups that are independent of each other. Researchers collect data from 2 or more groups with different conditions and compares the means in order to find out which group was most efficient. To use an independent t-test, scores must be unrelated to each other, which is true in our case since we have different conditions for each of our 4 groups, and that would be the amount of hours that they're getting. The distribution type for these tests are based off of the distribution of difference between means, and then t-tests can be seen as a between subjects test. For our method, research participants were instructed to sleep for their assigned duration for 1 month prior to taking the test. Participants kept a sleep log while also being monitored through the health app on their smartphones to ensure consistency. The app tracks the time in bed as well as the actual amount of time spent asleep in the bed, and it does this by monitoring breathing, sounds within the room, and then also movement within the bed. And I think it does all of this through the microphone, actually. Each group had 2 alternates maintaining the same regimen, just in case one of the subjects in a group could not maintain the routine. So if one of our participants did happen to slip up, we did have backup to fill in for them so that we could continue our research. For this month, subjects were asked not to nap during the day, but they were allowed to use caffeine up until 8 hours before the time that they planned on going to bed. On the 31st day of our experiment, subjects had now completed a full month of sleeping for their designated amount of hours. They were asked to meet us at UNLV to maintain their usual academic environment for them to take the test. The test we created for them was 30 questions long and 1 point each. The test was cumulative. It included lengthy basic algebra problems and reading comprehension passages and questions. All material was basic enough to know, but it only required competent attention to complete. Subjects were provided with healthy snacks and allowed to mingle before the individual testing began. This is to relieve any possible stress or test anxiety that could actually skew their results. The individual score results are as follows for each group. I'm not going to read out each individual score, but you can see we do have 3 scores for each participant for each group. So 3 scores for the control group, 3 for group 1, group 2, and group 3. These are the participant scores out of the 30-point cumulative test on basic academics. On the next slide, what we're going to do is we're actually going to find the average for each of these groups. And the way that we're going to do that is we're going to add up each participant's score. So we're going to take all of them and add them together, and we're actually going to divide them by 3 since there are 3 participants. And this is how we're going to get the mean or the average. So for example, for the control group, we're going to add up 28 plus 26 plus 25, and then whatever that sum is, we're going to divide it by 3 for 3 participants. You can see on this data page that we do have the chart showing the mean scores. In the very left column, this is just for what group it is, so control group, group 1, group 2, and group 3. The middle column is just signifying how many hours of sleep that group did get, so we're reminded. And in the very last column, the really important one, we have the mean test score for each group, which I just explained to you how we found. We are going to use the mean test score later on. So now that we have all of that information, we can actually start our hypothesis testing. So the first step in our hypothesis testing is just to state our hypothesis. So for population 1, that population is going to be the control group that's receiving 8 hours of sleep. Population 2 is all of those that are receiving less than 8 hours of sleep. So population 2 is comprised of group 1, group 2, and group 3. Our control group is labeled as group 4 in this experiment. Under that, you can see our research hypothesis, which is H1. H1 is suggesting that the mean of group 1 is not equal to the mean of group 2, which is not equal to the mean of group 3, which is not equal to the mean of group 4. This hypothesis does suggest that there's a difference between groups and that the amount of sleep that you get per night does affect your performance. The null hypothesis is H2, and that is suggesting that the mean of group 1 is actually equal to the mean of group 2, which is equal to the mean of group 3, which is equal to the mean of group 4. So it's suggesting that there's no difference between the groups, all of the groups have the same mean score, and the amount of sleep that you get really doesn't matter. Step 2 in hypothesis testing is to calculate the sample variance and the S difference, and also to check the assumptions. So the text on this slide I actually did borrow from the School of Psychology, University of England. I did link it below. I just think that the way they worded this was really well, and this is basically just the assumptions that do need to be true in order to calculate all of this. So for the first one, all observations must be independent of each other. This is true, like I said earlier, because we do have different conditions for each of our 4 groups within the amount of sleep that they're getting per night is all different within each group. For number 2, the dependent variable must be measured on an interval or ratio scale. Since our dependent variable is the test scores, this is true, it's a numerical value. And then number 3, the dependent variable must be normally distributed in the population for each group being compared. This is the normality assumption, and we are using a normal distribution for this experiment. For number 4, the distribution of the dependent variable for one of the groups being compared must have the same variance as the distribution for the other group being compared. Now we can start our actual calculations for step 2. So on this first slide, we're actually going to kind of work backwards. We're going to start with our control group, group 4. And if you can see the very left column, it just says 1, 2, 3. That is for participant 1, participant 2, and participant 3 of the control group. The next column that is labeled scores, that is the score for each of those subjects. And the column next to that where it says X minus M, what we did is we actually subtracted the mean of their group from each participant's score. So subject 1 score was 28, and we subtracted 26.3 from 28 since 26.3 is the control group's mean. From that number we got 1.7, and what we did in the last column is we actually squared that number. So for each participant, we found that difference and squared the difference, and then we added them all up. We found the sum of X minus M squared, which is 4.67. And we're actually going to do that for all of our groups, as we're going to find that sum, because we're going to use that sum later on. In the bottom left box, where it says n minus 1 equals 2, this is actually the degrees of freedom. Degrees of freedom is found by calculating n minus 1, which is the number of participants minus 1. And we're going to use this number again later too. I just want to point it out here. And so all of our groups are actually going to have the same degrees of freedom because they all have 3 participants, and 3 minus 1 is always going to equal 2. As you can see on this slide, we did the exact same thing for group 1. We took all of their participant scores, all 3 of them, we subtracted the mean from each of those scores, we got a difference, and we squared the difference. We added up all of the squares, and again we got 4.67. You can see once again we did this for group 2. And once again, lastly, we did this for group 3. So now that we have all of those calculations, we can kind of get down to business and start finding our S difference. But first, what we're going to do is find our sample variance for each of the groups. The way that we're going to do that is by taking this first formula, which is the sum of x minus m squared divided by n minus 1, which is the degrees of freedom. The sum of x minus m squared is the number that we calculated on the previous slides for each group. The n minus 1, the degrees of freedom for each group, is going to be the same as we said before, since each group does have 3 members, and 3 minus 1 is always going to be 2. So each group is going to divide by 2. You can see that we did those calculations under that first formula. So for group 1's s squared, we got 2.34. For group 2, we got 2.5. For group 3, we got 5.94. And then for group 4, our control group, we got 2.34. The next formula that we have here is going to be for our S2 pooled. The way that we're going to find our S2 pooled is by taking the degrees of freedom for the first group, and then dividing it by the degrees of freedom total. The product that we get from there, we're going to actually multiply by the sample variance that we got from the previous formula. So we're going to do that for each group, and then we're going to add it all together, which is why you see in the formula we then add it again and do the same thing for group 2. So we take the degrees of freedom for group 2, divide it by the degrees of freedom total, and then we're going to multiply it by group 2's sample variance. So multiply it by 2.5, which you can see we did all of those calculations under that formula. The degrees of freedom total, the way that we're going to find that is we're going to take the degrees of freedom for every group, and we're just going to add them all up. So since we have 4 groups and every single group has a degrees of freedom of 2, we know that 2 plus 2 plus 2 plus 2 does equal 8. So our degrees of freedom total is 8, which is what we're going to be dividing by in our S2 pooled calculations. As you can see, the value that we get for our S2 pooled after we calculate all of that is 3.3. The next formula under this is going to be for S2M. For S2M, we are going to get one of those for each of the groups, which is why you can see we have S2M subscript 1, and then we also have S2M subscript 2, and we'll have one subscript 3 and subscript 4 as well. So the way that we find that is by taking the S2 pooled, which is the number we just got, 3.3, and we're going to divide it by the n for each group. So you can see we divide it by n1. In the second part of that formula, you see we divide it by n2. So we're just going to do that for every group. But like we said, every group has the same n, and since n is 3, because they all have 3 groups, for every group we're going to get the same number. We're going to divide 3.3 divided by 3, which is going to give us 1.1 for every single group, as you can see under this formula. So our next formula is going to be to get the S squared difference. And the way we get S squared difference is simply by adding up all of our S2Ms. So we're going to take 1.1 plus 1.1 plus 1.1 and plus 1.1 again. That is going to give us a total of 4.4. The last formula on this page is for S difference. And the way that we get the S difference is simply just square rooting the number we just got, which is the S squared difference. So once we square root that, we are going to square root 4.4, and that's going to give us a value of 2.1, which I did highlight on this page just so it's easier to see, and we are going to use that number again later. The third step in hypothesis testing is calculating the test statistics. So what this means is that we're going to find our cutoff score or our critical value point. This is what we're going to actually compare to our sample t-score. In order to find this, for p, we're going to use 5% or the value 0.05. I think p is also called the alpha value or alpha level. Our equation is one-tailed, which is important for when we find it on the t-table. And then the degrees of freedom that we're going to use is 3, because the degrees of freedom again is n minus 1. And in this case, n actually equals 4 since we have 4 groups total. So 4 groups minus 1 is 3. So we're going to use the degrees of freedom of 3. We will use this information to locate the cutoff score on the t-distribution table. I didn't put a picture of that in here, but they are very easy to find online, or most students do have them on hand. And the value that we get from this is 2.13. I did put a graphic next to this where you can see what the p-value is. There's the little blue section on both sides. This would be for a two-tailed test, and we're actually only doing a one-tailed test, so we do have 5% only in one end. But this just kind of helps visualize it and understand what the p-value is and kind of what we're getting from this t-table. So now that we're done with step 3 and we have found our critical value point to compare to, now in step 4 we're going to evaluate our result, and this means we're just going to find our t-score for our actual sample from our experiment. So the formula for t-score is going to be mean of group 1 minus the mean of group 2 minus the mean of group 3 minus the mean of group 4. That difference you are then going to divide by the S difference, which we found earlier. Our S difference was 2.1, so you can see we subtracted all of the means and then divided that again by 2.1, which gave us negative 13.76. The last step is step 5, and this is where we're going to interpret our results. So the first thing that we did was take the absolute value of our critical value point, which is 2.13, and we took our absolute value of our sample t-score, which is negative 13.76, with the actual value would be 13.76. Since the absolute value of negative 13.76 is greater than the absolute value of 2.13, we can see that there's a difference in scores between the control group and the treatment groups. They are not equal. So because of this, we are going to reject our null hypothesis. And I did put our hypothesis, our research hypothesis and null hypothesis back in under this just to help visualize what this means and which one we're keeping or rejecting. So we're going to keep our first one, which is H1, because this one did suggest that there's a difference between scores and there's a difference between your performance based on the amount of hours that you're sleeping. H2 is our null hypothesis. This is the one that we're rejecting because, again, this one suggested that all of the means would be equal, and we know that they're not now that we've tested it, so we can, with full confidence, reject that one. Just to kind of put into perspective what this means and kind of to conclude everything, college students that received 8 hours of sleep per night had higher performance scores than the college students that received less than 8 hours of sleep. Because of this, and because we know this now, we can infer that once life is back to normal, we're out of quarantine, and we can return back to university regularly, that students will likely return to a normal sleep schedule that is closer to 8 hours of sleep per night, and that in turn, this is going to restore their academic performance, and hopefully we're all going to start doing a little better on our tests once we get some more sleep. Or a more normal sleep schedule. So thanks for watching. Yeah, thanks for watching.